In this video, I'm going to discuss about the log, but this time is a little bit different. I'm going to discuss from the very basics, okay? Because a lot of students say that actually they have the difficulties in when they want to solve the log questions. So now the first question is, a lot of students might ask, when do we use log, right? When do we need to use log? For example, let's say, okay, 2 power of x will equals to 8. Okay, for the question like this, I believe a lot of students can actually solve it easily. If you learn about indices, you know this is indices. Okay, why I say this is indices? Because we know actually 8 is 2 power of 3. So I can actually write like this: 2 power of x equals to 2 power of 3. Then when we have the same base, we can straight away compare their power. X will equals to 3. So I say this is indices. So indices is not what I want to discuss over here. So just ignore this one. Okay, how about if I use log to solve this question? Let's say 2 power of x will equals to 8. Alright, so if I use log to solve this question, what I need to do is, okay, I try to add log base 10 for both sides. Alright, and then the law of log tells us that the power, actually we can move in front. Correct or not? So we have got x will equals to, we have got x, because I move in front already, log 2 will equals to log 8. Alright, then what you can do is, okay, this is x multiple log 2, right? So x will become log 8 divided by log 2. Okay, if you got something like this, you can press calculator. Log 8 divided by log 2. So I believe you will get the answer 3 also. Okay, so basically you can use the log to solve the indices question. You got back the same answer, but we have some types of question actually you have to use log. For example, let's say 2 power of x equals to 10. Alright, over here we know that no matter how we simplify the 10, we cannot get 2 power of anything will equals to 10. So in these cases, we have to use log. We got no other way to solve it. So same methods, we add log for both sides. So log 2x equals to log 10. Alright, then what we do is, okay, power we can move in front, it will become x log multiple log 2 equals to log 10. Okay, when I never write any things on the base of log, actually we know this one means base 10. Okay, in log actually we got one law is something like this. If log a will equals to 1, mean actually if the base and number is the same, is equals to 1. Therefore, this one is equal to 1. So x will equals to 1 divided by log 2. Then you can press the calculator. 1 divided by log 2, you will got the value. X is equals to, okay, let's say I round off is 3.32. That means what? That means x power of 3.32, you will got 10. Okay, this is the purpose of log. So most of the time when we use log is something like this. When our power have decimal, okay, means when our power is like fraction or decimal, so we have to use log. Okay, so if this happens to in your exam, most of the time if the question you can solve it using indices, use indices first, because normally log will be more complicated than indices. But then of course some of the question you purposely want you to use log. So whenever you see the question like like this one, or sometimes they will write something like 2x equal to 100. And then if you know about the power of 2, you know it's impossible to get 100, because like 2 power of 6 you will got 64, and 2 power of 7 you will got 128. Therefore you got no way for you to get 100. So the example like this one, you know you have to use log. For example, 3x equals to 100. You know this one you have to use log, because 100 is not 3 power of something you can get 100. So for the example like this, you have to know you need to use log. Of course, we have some question is like not only press calculator, he asks you to solve it. So that one you need to be very good in the law of the log. Alright, so do not waste your time. So we go into some basic formula. I hope this one can give you some basic. I think the log video, actually I will make 2 videos for log, because it's a bit too long if I finish everything in 1 video. So yeah, so I think this is the first video. After this video, if you want to know better or know more deeper about log, you just find the second video. Alright, okay, let's have a look over here. This is some basic but very useful law for log. Alright, for example, the first one is very important. Okay, for example, okay, I just randomly give you some number because I want to give you some idea. Alright, let's say I got log 2n equals to 4. I want to find n. So what I can do is, actually I can move the log 2 to the other side. I can move the log 2 to the other side. But when I move the log 2 to the other side, what will happen is the 2 will become the number. You see, a now he become the number, and x become the power. So if I move log 2 over there, 2 will become the number and 4 will become the power. So you see what will happen is, okay, I want to find n. So n will equals to, this is base 2, right? So base 2 will become number, the 4 here will become power. So therefore n is equals to 2 power of 4, which is 16. Alright, of course, when I got this symbol, I know actually I can change it back. So when you change it back, of course you need to understand this one very well if you want to do something like changing back. So let's say n is equals to, let's say I just randomly give some number, let's say 3 power of 5. So if I change back, I from this one change back to this one, so what I will got is, this one will become base, so this one is log 3, n will equals to 5. Okay, this is the way you changing back. You see, the number now will become the base, log base 3. And then the power now will become the number on the opposite side. Alright, so of course, most of the time is this happen. This one seldom will ask you to change from this one to this one. So most of the time he will give you this one, and then ask you to find n, or ask you to find, sometimes give you x or y. So you must know one thing very important is the log 2, you can move the log base 2 to the other side. The base 2 will become the number 2 and 4 will become the power. So you got something like this. Okay, please practice this one in your own, okay, in order to fully understand about this one. Alright, okay, then we come to this one. Okay, this one, when you got log a x y, so over here I always recommend my student to put the bracket for x y to make everything very simple, because when we see bracket, we know actually it's log a's and then something like multiple x and y, and then x y means x multiple y. Alright, this one is very simple. So for example, I got log, I just simply give a number, log 2 4x. Okay, if I got log 2 4x, so what I know is 4x means what? 4 multiple x. 4 multiple x, that means if I expand this one, the multiple will become plus. Inside the bracket, multiple will become plus. So I will got log 2 4 plus log 2 x. So actually when they are multiple, actually I can separate like log 2 for plus, because it's multiple, right? Log 2 x. Alright, and there's a lot of students were confused about this one and this one. Let's say log 2 4 plus x. Okay, if you got log 2 4 plus, and some students say multiple is plus, then is it means that plus will become multiple? No. This one you won't expand become like log 2 4 multiple log 2x, no such thing. So if you got something like this in your exam, first thing is when log bracket inside is plus or minus, this one you cannot explain. You cannot expand. Remember, this one you cannot expand, meaning you cannot do anything for this one. No way for you to expand. You have to leave like this until the other side got log 2, then you log 2 and log 2 is simplified. So remember, this one is very important because a lot of students, when he see something like log 2 4 plus x, he going to expand maybe log 2 4 plus log 2x, or he expand a log 2 4 multiple log 2x. All is wrong. Because when you got log bracket is plus or minus on the middle, you cannot expand for this one. Remember this one. This is very, very, very important. Alright. Okay. So over here, minus. Okay. When you see bracket, you got divide. Mean actually when you expand is minus. So for example, I got log 2. Let's say 4 over x. Okay, inside the bracket divide mean minus, inside the bracket multiple mean plus, but plus is we cannot like things the other way around. Okay, so if I got log 4 over x, I know I can expand this one as log 2 4 divide, right, minus log 2x. Alright, so if the exam want to trap you, he might give you something like this, log 2 4 minus x. So like what I say, this one you cannot expand. Okay, you cannot expand for this one. Remember this is important also, because lots of students tend to expand either this one or this one. Okay, you got the bracket inside is plus or minus, cannot expand. Please remember this one in order to like do well over here. And okay, this is very simple. This is something like if you got the power q, you actually can bring your q's to in front. Okay, become q multiple log ax. So it become q multiple. This is multiple. So at the same time, we know that if I got the power in front, I can bring it up, become the power as well. So for example, if I got log 2x power of 7, I can move my 7's to in front, become 7 multiple log 2x. They are the same thing. Alright, so I can still move it up, move it back, then I will got log 2, the 7, I move it back, become x power of 7. Alright, a lot of students will make the mistake, something like this. When you move it up, he will become log 2x. Total power of 7. This is wrong. Alright, because when you move the 7 up, the 7 is only the power for x. Okay, it's only the power for x, not the power for the whole thing. So this one is wrong. Alright, remember this is wrong. Okay, so okay, this 1, 2, 3, 4. Okay, 4 of this law is quite important in our following example. So hope you can really understand, and it's possible take some time to do some exercise or practice for this one, because log, in order to competence on this topic, you need to do a lot of practice. Okay, come. The first one. This is the simplest one. Okay, if in the exam you will see log 10x equals to 2.63. He asks you to find x. So actually it's very simple. Just now I say this is log base 10, right? This is number, right? So if I move the log base 10 over here, I will got 10 over here. Number will become the power. Okay, so therefore some reference book actually what he teach is the log move to the other side becomes shift log. So he will ask you to press shift log. So actually shift log you will got something like this. 10, and then you press 2.63, and then you will got the answer is 426.6. Alright, so actually this one you can press shift log, or you can press 10 power of 2.63. You will get back the same thing, you see, 426.6. Okay, so actually it's the same thing. So what you need to know is the base move to the other side become number, and the number will become the power. Okay, so again, we do again. So now this is base 2, right? I move to the other side, 2 will become number, and the 5 over here will become power. So 2 power of 5 is 32. That's all. So y will equals to 32. Okay, so actually it's very simple. Okay, like this one. Now the base is y, right? So if I move the log base y to the other side, what I will got is 8 will equals to y power of 3, because 3 will become power if I move the log to the other side. Okay, then we want to find y. We know 8 actually is 2 power of 3 equals to y power of 3, so y will equals to 2. That's all. Alright, I hope you can understand this one, not really hard. Alright, this is some basic law about log. Alright, it's just move the log 10 to the other side. Okay, of course, this is something extra, not to confuse you, but I'm trying to make you understand about this one. Okay, why this thing can happen like this? Okay, actually it's something like this. Okay, I just explained in extra. Okay, I use back the same example, see whether I can get y equals to 32 or not. Okay, log 2y equals to 5. Okay, what is happening is, if here is log 2, but then here I do not have log base 2, so what I do is, I try to make both sides have the log base 2. So over here, you can see actually, I multiple log 2. Because just now we learned that log a equals to 1. So this one actually is 1. So 5 multiple 1 is still 5. So actually I never changed the equalities of the equation. So this one is 5 multiple 1, right? So I can add anything as I want. I can add log 3 or log 100 log 99. Because this one is equal to 1. 5 multiple 1 is still 5. So this equation is still correct. Unless you suddenly change something else, the equation is not correct. But this one is still correct because this equation is same with this one. Alright, so we learned the law just now. We know that the number in front we can move up, become power for 2. Correct or not? So this one I will call this one is log base 2 power of 5. Okay, this is what we learned just now. And then both sides we only have log 2 and log 2. We can simplify it. So therefore y will equals to 2 power of 5. So therefore y will equals to 32. You can see both is actually getting the same answer. So actually why the log base 2 move to the other side become 2 power of 5 is because of this one. He give you the formula, he just want to skip some step for you. You see here actually I need to use 5 steps to get 32. Here I only use 2 steps. So actually if you can understand the formula, you can do it faster. But if you cannot understand this one formula, I also hope you can understand this one. At least you still can get the answer for y. Alright, this is something extra. Okay, come. We continue. Alright. Okay, for this one actually is, okay, what is the value for this one? So I trying to simplify this one. So whenever you see base, you always check whether the base and the number over here got relationships or not. 3 and 27. Obviously 27 can divide by 3, and then I also know that 27 actually is 3 power of 3. Therefore when you see the relationships, it's very important in log. Alright, so therefore I know this is log base 3 power of 3. Correct or not? And then the law just now tell us that 3 I can move in front, become 3 multiple the whole thing. So will become 3 multiple log 3. And then just now I said log a will equals to 1. So log 3 is equal to 1. So this one called 3 multiple 1. So therefore will equals to 3. So therefore, we know log base 327 is equal to 3. It's very simple. Alright, so, okay, this one we do it later because this one will be slightly complicated. We come to this one. Okay, log 10. So base 10, you have to see the base 10 and 10,000, any relationships. So we know actually 10,000 is 10 power of 4. Correct or not? So this one I call it log 10, 10 power of 4. And power, we can move in front. Become 4 multiple the whole thing. So 4 multiple log 10, 10. And I say log AA equals to 1. So log 10, 10 equals to 1. So this answer is 4. So, if you not believe, you can still press the calculator, log 10,000, you will get the answer 4. Alright, so, yeah. So, okay, let me press to show you. Okay, log, where's log? Okay, log 10,000. So, you got 4. See? So, if you can understand, you can do it very fast. Okay, come, this one. Okay, this one, how to solve the question like this? Okay, this is 9, this is 3. Okay, of course I know 9 actually equals to 3 square. Alright, but then now the problem is 9 is the number, it's a base, 3 is the number. When you see the example like this, base is bigger than number, this one will be a little bit hard to solve. So what I can tell you is, I know actually 3, I can change it to the square root of 9. At least I can see the 9 over here. Because square root of 9 is equal to 3, isn't it? And indices tell us that square root means power of 1 over 2. This is square root. So therefore what I do is, I change the 3. This is log base 9. I change the 3 become 9 power of 1 over 2. Because later I want to simplify log 9 equals to 1. And then I know 1 over 2 I can move in front because the law says so. So I will got 1 over 2 multiple log 9 is 1. So this answer is equals to 1 over 2. Alright, of course this kind of question you can still use the chain base method to solve it. But then in this video I'm not going to cover the chain base. So I'm going to cover the chain base in the second video. So therefore I teach you all using this method. So yeah, I just hope this method didn't scare you out. Alright, so let me continue with few more paper. Now it's 22 minutes already. Right. Okay, what happens if you got the question something like this? Okay, just now we learn a law says that let me take another. Okay, we learn a law says that log a xy will equals to log a x plus log a y, isn't it? I say, okay, so you see both of this one is log a because this is log a, and then this over here is multiple, so it will become plus. But then now I want to change from this one go back to this one. So I want to change from this term come back to this one. So what will happen is, this one we call it factorize out log 6 from both sides. So if I factorize out both sides, log 6 I take out from both sides. So I take out log 6 over here and take out log 6 over here. So when middle is plus, they will become multiple. 54 multiple with 4. Okay, then 54 multiple with 4 we will got 200 and we will got 216 if not mistaken. 216. And actually I know that 216 is related to 6 because 216 actually is 6 power of 3. Alright, so I'm going to change this one to log 6 power of 3. So obviously we know this one will equals to 3. Why? Because 3 you can move in front, become 3 multiple. Log 6 is 1. So the answer will equals to 3. Alright, so this is what happens when you factorize plus will change back to multiple. You see, if I factorize out log A here, the plus over here will become multiple. Alright, so if I factorize out again log 3 from this example, minus will become divide. So I will take out log 3 from both. So I know that minus means divide. So 45 divide by 5. Because minus means divide 5. Okay, you can try to expand this one, you got back exactly the same thing. Divide become minus, multiple become plus, isn't it? So this one actually can reverse back to this one. So you always check whether you factorize correctly or not. You see if you expand this one, can you get back this one? Alright, so this one is simple because 45 divided by 5, we got 9, and of course I know 9 actually equals to 3 squared because it's base 3. So 2 I can move in front, this one will become 2. Simple? Okay, I hope you can understand about this one. Then let me move on. This is simple. Okay, what happened to this one? Okay, obviously we know 4 and 16 got relationships because 16 is 4 squared. But then this is 1 over 16. Okay, so when you see 1 over 16, in indices we learn something like this. 1 over a, we call it a power of negative 1. So if 1 over a square, we will call it a negative 2. Alright, so if 1 over 16, we can call this one is 16 power of negative 1. So 16, we know this one is 4 squared, power of negative 1. So this is 4, negative 2. Alright, so you have to know actually you can change 1 over 16 to 4 power of negative 2. This is not really hard, but then you need to go in indices. So I change this one to log 4, 16, right? So it will be 1 over 16 is 4 power of negative 2. We know negative 2 we can move in front, and log 4 will become 1, so it's negative 2. Alright. Okay, same thing to this one. Okay, now is 4 multiple the whole thing. So whenever we see 4 in front, the law tells us that we can move up, become power of 4. So this one is log 16, 2 power of 4. So 2 power of 4, you press calculator, we know is 16. So log 16 is equal to 1. Alright. And then for this one, okay, this one got plus and minus. And then you want to factorize out log 3, you have to make sure all is 3. Huh? If they are different base, you cannot factorize all together because they are different. Alright, so if I one time factorize out log 3 from all of this one, what will happen over here is plus will become multiple, minus will become divide. So this one called 6 multiple 9 divide by 2. So I will got 6 multiple 9 minus, right, divided by 2. So this one 6 multiple 9. Okay, 6 multiple 9, we will got 54. 54 divided by 2, we will got 27. So this is log 3, 27. Obviously, 27, we know this one is 3 power of 3. Then we can move the 3 in front, so this one equals to 3. Alright, so I hope this one can give you more insight on how to do the factorize and everything. Alright. Okay, let's see, we still got a few more before I end this video. Alright, this one. Okay, same thing, we know actually this is called 1 over 3 log 9 27. Alright, so for the case like this, okay, is this one actually will same with example like this? Because some students when they see something log 9 27 over 3, they do not know actually this one is same with this one, because if 1 over 3 multiple in this one, you will get back exactly this one. Correct or not? So this one actually, you have to understand, you can take out 1 over 3, become like this. Then you know this is multiple, move up 1 over 3 here, you will know this one will become power. Alright, so this one you got log 9 27 power of 1 over 3. We know power of 1 over 3 actually mean cube root, correct or not? This one will mean cube root 27. This is power 1 over 3. Alright, so cube root 27, we will got 3. Okay, this one actually we solved just now. We can change 3 to 9 power of 1 over 2 because 3 equal to square root of 9. So therefore the answer is 1 over 2. Alright, so 3 can change to this one because square root of 9 is equal to 3. Alright, then log 9 will become 1. So 1 over 2 I move in front, become 1 over 2 multiple 1. Alright, not really hard, right? So same to this one. Okay, this one is actually quite similar with just now one, but then the problem is he got 1 over 2 over here. So whenever you see the number in front of log, if possible, try to make this one on the top become power first. So obviously I will move the 1 over 2 over here becomes 16 power of 1 over 2. Okay, so this one will become log 8 32 minus log 8 2 plus log 8 16 power of 1 over 2. Okay, we know power of 1 over 2 means square root 16 is equal to 4. So this one actually is equal to 4. Alright, so and then I factorize out log 8 from all of the number over here. So minus will become divide. So and plus will become multiple. So this one 32 minus divide 2 multiple 4. Alright, this is very important because some students will make the mistake like this. Because okay, 32 divide 2, okay, most of you get correct. And then he said plus 4, multiple 4, then 4 should I put on the top or on the bottom? This one obviously is put on the top. Unless he put the bracket for it, then only you put the 4 on the bottom. Because put the bracket means actually you have to solve inside the bracket. If you didn't put the bracket, plus is always on the top, minus is always on the bottom. Alright, so hope you can understand this one. Okay, then of course we can simplify 2 and 4, so you got 64. So log 8 64, obviously we know 64 is equal to 2 square, x square. So x square, so answer will be 2. Alright, okay, last 2 questions before I end this video. Yeah, okay, for this one, okay, he gives you some information. He said log P3 equals to m and log P5 will equals to n, and they ask you to express this one in terms of m and n. Alright, so in order to solve the question like this, obviously you need to know how to expand this one. So I write down the question first. Log P bracket. Okay, this one I know is 125 multiple P. Because 125P means 125 multiple P, isn't it? Divided by 9. Alright, from the law just now we know multiple, if we expand become plus, divide become minus. So actually it's very simple. So what I will do is, I will write something like this. Log, okay, this is log P, follow back log P, 125, multiple, right, plus log P, P, divide, right, minus log P, 9. Alright, and then we know we have to get something like log P5. This is log P, 125. What is the relationship between 125 and 5? 125 is the 5 power of 3. Okay, so I change this one to P 5 power of 3. And then log PP, obviously we know this one equal to 1 because base and number is the same, so equals to 1. Minus log P, we know 9 actually is, what is the relationship between 9 and 3? Is 3 square. Okay, so what we do is, for next step is we move the power to in front. We move the power to in front. Alright, so this one will become 3 multiple log P5 plus 1 minus 2, I move the 2 in front, multiple log P3. Then you almost done because it said log P5 equal to n, right? So this one called 3n plus 1 minus 2 log P3 equals to m. So if you want to rewrite, make it nicer also can. 3n minus 2n plus 1. I'm done. Alright. So of course when you see something like this, please remember how to expand this one. It's not really hard, but then you need to understand that multiple will become plus, divide will become minus. Alright, last one. Okay, then I end this video. Alright, this one actually very simple, but then I just worry not enough example for you to understand this one, so I just add on another one. Alright, so when you see number in front of the log, I say they are always multiple. That means we can move this one up to become power. So 3 multiple this one, so we can move the 3 up, become power. Alright, but the difficult part in this question is the 4 over here, he do not have the log base 4. So you cannot factorize out this one. So you have to add it yourself. Just now I said you can add whatever you like as long as you have to make sure 4 is multiple 1. Alright. So come see how I do is, okay, this one will be log 4 64 power of 1 over 2. Okay, 1 over 2 move up become power, nothing surprise you. Alright, so minus 4. If 4 multiple 1, I say log A equals to 1. Just now we know log A equals to 1. So now I need log 4. So if I need log 4, I have to log 4, 4. 4 multiple 1, I get back the 4. So I never change the equalities of the equation. Alright, so plus, I said 3, you can move up, become power. This one called log 4 2 power of 3. Alright, obviously this is 4 multiple the whole thing. We can still move the 4, go up, so it become power. But we solve this one first. This is log 4, 64 square root, we will go 8 minus, okay, this one called log 4 power of 4. Okay, what is 4 power of 4? If you are not sure, you can press calculator. I think log 4 power of 4 is 256, isn't it? Let me press 4 power of 4. Yes, it's 256. So this is, I move the 4 on the top, will become 4 power of 4, right? So it's 256. Plus this one, you got 2 power of 3 is 8. Alright, now all got base 4 already, you can factorize out. So log 4, I say factorize minus become divide plus become multiple. Alright, so you see, you have to see like this. From the first one, this is 8, right? Minus divide 256. Plus always right on the top unless you got the bracket. Alright, so plus 8 multiple 8. Okay, then we do some simple calculation. This one is log 4. This one will be 64 over 256. If not mistaken, 64 over 256 is equals to 64 divided by 256. Yeah, you got 1 over 4. So this one is become log 4 bracket 1 over 4. Alright, I say 1 over 4, we can write 4 negative 1 because of this indices law. Correct or not? So this one I can write as log 4 power of negative 1 because of this indices law. Then I can move the negative 1 to in front. Multiple log 4 is 1. Negative 1 multiple 1, we got answer is negative 1. Alright. I really hope this video can give you more insights to understand about log. I already try my best to get some simple example, and then I try to make it very easy to understand. So I hope this video you really can understand about a basic of log. Obviously I will do the second videos which is more difficult, and then I will put in some past year questions to make you like fully understand about this chapter. Anyways, hope you enjoy this video.